Hello, my name is Brandon Clayton, the Algebra Guy, and today, as you see on your screen, the discussion will cover how to set up and solve proportions. So proportions are very important, and they come up quite a bit when dealing with rates and ratios and whatnot. So let's look into it. We got quite a bit to cover today. The questions that we want to answer are as follows. How can we use a definition of proportion? How do we solve proportions? How do we solve them in word problems? How do we write percent equations as proportions? So we've done it as equations, but how do you set up a percent as a proportion? And how do we translate and solve percent proportion? So let's get into it. So I'm going to leave you quite a bit of practice problems as we go through here. So please continue to remember to pause it and work the problems as best you can before watching me do it. All right, so the definition of proportion. So what is a proportion? A proportion is an equation of this form. So let me pull this up. So a portion is the equation of this form. A is to B equals C is to D, where both the denominators are not equal to 0 because it'd be undefined at those points. The proportion states that two ratios or rates are equal. The proportion is read A is to B and as C is to D. So here's an example. The equation 1/2 is equal to 4/8. Is a proportion. Why? Because the two fractions are equal. The proportion 1/2 is equal to 4/8 and is read 1 is to 2 as 4 is to 8. They're both equal. That's what they're saying. 1 is to 2 just as 4 is to 8 in the same proportion. So we'll look at some examples with that. Here's our first one. If we compare quantities with units, we have to be sure we're comparing them in the right order. For example, if you have 20 students for every teacher and I want a proportional relationship to that, I could say that's the same thing as 60 students for every 3 teachers. So we compare the number of students to the number of teachers. We put the students, we keep the units in the same place, the students on top and the teachers on the bottom. All right, let's practice that. So how would I set these up as a proportion? 3 is to 7, just as 15 is to 35. So that's how I would set that up. Pretty simple, right? And 5 hits and 8 bats. So you got 5 hits. I should have put the units here. Oh, there was no unit, so that's fine. Add 8 bats is equal to 30 hits at 48 bats. So notice my units are in the denominator and my numerator has hits. $1.50. $1.50. That's my units are dollars, so I'm gonna keep the dollars up top. Every 6 ounces. There you go. Abbreviation for ounces is OZ. Is the same, is equivalent to 225 for 9 ounces. So there you go. So it's important before we try to solve anything that we know how to set these up. All right, so what about the cross product test for equality? What does that mean? What this is saying is that now that you know how to set it up, if you needed to solve for a variable, you needed to find one of these 4 pieces, you could do so by remembering the cross products of a proportion. This is saying as follows. If you have this situation A over B equals C over D, you could multiply the denominator times the numerator and the denominator over here times the numerator and get the following. A times D is equal to B times C. So it's going to still be equal to each other, but this puts it in an equation format by which we can solve for that variable. Now we can look further into why this works if you're interested, which most people aren't, but I don't care for this method a whole lot sometimes because it's not a mathematical thinking, it's just cross multiplying. You just start doing things and wondering, is this what I'm supposed to do? But in essence, what you're doing is you're multiplying both sides by B and D. You're multiplying this side by B and D, and you're multiplying this side by B and D. And when you do that, these B's cross out and leave you with a AD up top, and these D's cross out and you live for the CB up top. So you're keeping this proportion equivalent by multiplying the same thing on both sides in order to get rid of those denominators. And we're left with the other part of that denominator, D in this case and B in this case over here. So that's how you end up with that. So it's just in case you're curious and you want to know the math behind why that works. Because that helps tremendously. I'm going to tell you, seek understanding. My goodness, though it costs you everything, seek understanding. Don't just look for patterns and copy and plug in, but try to understand because it'll serve you for the rest of your life. All right, so determine whether each equation is proportional. So let's see if these, using what we just learned, let's see if these are equal. So we know we can set this up. 4 times 28 is equal to 9 times 12. So if these do come out equal, we know that this is true. Now, to be honest with you, I wouldn't do it this way, and I'm going to show you why here in just a second, because it's just not necessary. There's something you can do a lot faster to see if these are equal, but let's check. 4 times 28 is 112. So in order for this to be true, this side needs to equal 112, and I'm pretty sure it's not. So let's do, it's going to be pretty close, but not equal. So this is 108. So this is not equal. So these are not proportional because they are not equal. These are not equal. Now, how would I know that? Like I was saying earlier. Well, one of the things you can do is since I know how a proportion works, that means it needs to be you need to be able to multiply by the same factor. Since we're saying 4 is to 9, that's 12 is to 8, they're being multiplied by the same factor. In other words, if it's getting twice as big on this side, it needs to be twice as big on this side. Or if it's twice as big from 4 to 12, it needs to be twice as big from 9 to 28. In this case, I'm looking at 4 and 12, and I notice that it's 3 times bigger. 3 times bigger. Well, since that's true, it needs to be 3 times bigger down here. And just doing that math in my head, right, 9 times 3 is not 28, it's 27. So when I saw that, I said, oh no, I know those aren't equal. Now, it's tougher to do that here with a decimal in your mind, but when you do get these problems that you can do in your head, use that knowledge to kind of quickly check. All right, so let's set this one up to see if it's equal. So let's say 15, all right, so 15 times 17.5 is equal to 37.5. And it doesn't matter what order, right? Because multiplication is commutative. You can put them in, 15 first or 17.5 first. Let's check 15 times 17.5, 262.5. Let's see if that's indeed equal to this other part here. So we have 37.5. Oh, 37.5 times 7. And we get the exact same thing. 262.5. So we know that this is a proportion. All right, what if we were used to solve a proportion containing a variable? What if we had a variable here? How would we do it? So we do the same thing like we've been doing. In the next example, we'll solve a proportion by multiplying by the least common denominator using multiplication property of equality. So what am I saying there? So you could just simply go across just like we did before and set this up with 7x and 63 times 4. Sorry about that. 63 times 4. And that gives us, pull up my calculator, 63 times 4 is 252. So I know that 7x is equal to 252. And I'm going to divide by 7 on both sides. Doing so gives me, it's divided by 7, 36. X equals 36. We could check our answer here by putting 36 in here, and we could divide it and to see if we come up with the same thing. Do 36 divided by 63, 4 divided by 7 to see if it gives us the same value, and I'm sure it will. But you can double check that on your own. Least common denominator. The least common denominator here would be 63. That's another way you could look at this, is to say I want a 63 on both sides. So since I have one here, and I multiply it on this side, I can multiply it on this side using that idea of equality. So they're still the same exact thing, but now you can cross out this 63. That leaves us with x equals, and then 63 over 7 is going to be 9. 9 times 4 is 36. So I did that kind of quick. So let me break that down. 4/7 times 63 over 1 is the same thing. Because these are commutative, I realize it can be 63 over 7 times 4 over 1. See, all I did was switch places here because it doesn't matter the order of multiplication. These can go first. So when I do that, I realize that these are just dividing into a 9, leaving me with 9 times 4. And that's how I got my 36. So that's a quick way of looking at it. And that's what they were talking about here by saying we can use the property of equality, multiplication property of equality. So that's a lot faster. But I want to show you there's many ways you can get there. All right, what about this one? I want to multiply. I'll use cross product here. We could multiply both sides by, let's do that. Let's multiply both sides by the least common denominator, which is 4a. 4 times a. This is 4a here. And you remember I told you that's really what's going on anyway with cross multiplying. So 4 times a, 4a times all of this, these a's are going to cross out, leaving me at 4 times 144. 4 times 144. And these 4's are going to cross out here, leave me with 9a. So now use my hefty defty calculator to do 144 times 4, and that's 576. Equals 9a. Now we divide both sides by 9, and we get 64. So a equals 64. All right, so solve application problems using proportions. So just remember to keep our units in the numerator. The units in the numerator and the denominator need to match. That's not actually always true. But for right now, you can do it that way just so you can have a pattern. But there's more than one way you can do it because you just need to be consistent. But I'll see if I can show that later. But if not, we'll just stick with this for right now. When pediatricians prescribe acetaminophen to children, they prescribe 5, let me get this set up, 5 milliliters of acetaminophen for every 25 pounds of the child. 25 pounds. So look at my units. Milliliters up top, pounds on bottom. If Zoe weighs 80 pounds, so pounds are still going to be on bottom. Just because they said it first, don't be tempted to put it up top. We're going to keep the units the same. So 80 pounds. How many milliliters? So we want to know this piece. How many milliliters of acetaminophen with her doctor? So if this is the rate that we're using, we want something equal to that. But this time it's 80 pounds. How much should we give? And this is why it's important to know your numbers as a nurse, because sometimes you have to do these calculations pretty quick if someone's in need. So let's do that. Actually, one of the things you can do, when I say an equivalent fraction or a fraction that can be simplified, sometimes breaking it down into a smaller fraction like 1/5, so this would be milliliters and pounds, makes it a little bit easier. So I'm going to do that here. We're going to keep this 80 pounds, nothing I can do with that. Why did I do that? Because when I do that, when I have a 1 and 5, it's a lot easier to work with. And I can see that if I wanted an equivalent fraction, proportional fraction, I need to find a number that multiplies 5 by 5 to get 80. And that would be, I think, 13. 13 times 5. 5, 1. No, that's, what is that? 50, 30 more, 16. So 16 times 5. Yeah, so that'd be 16. So I know multiplying by 16 down here. And since this is proportional, guess what up top is going to need to happen? Multiply by 16. And so I can see that my x, 1 times 16 is going to be 16. So what's the answer? She's going to need 16 milliliters. So if they're 80 pounds. So that's what we're saying. They're going to need 16 milliliters if they're 80 pounds. And why is this necessary? Again, in the medical field, being able to reduce that really quickly and say 5 times something gives me 80. Oh, that's 16. So 1 times 16, that's going to be 16 milliliters. So you could do that without having to set up the proportion. Now, I do want to do this one other way, since I have taught you how to do it a different way. And I want to show you that it does work no matter which way you choose. I'm going to use yellow for this. So I originally set this up 5 over 25 equals x over 80. So let's go about the same way we did it before. Cross multiply 80 times 5. 80 times 5 is going to be equal to 25x. And I'll take out my calculator and do 80 times. Actually, I don't need to do that, do I? I already know what that is. I already know that was 400. All right, so that's 400 equals 25x. And how many quarters are in $4? 16. We already know that. But I'm going to go ahead and divide it. Divide it by 25. 400 divided by 25 is 16. So we can still see it's the same answer. I just want to show you that no matter how you do it, it's going to come out the same way. And sometimes you need to prove it to yourself so you have that confidence. All right, one brand of microwave popcorn has 120 calories per serving. So that's per one serving. A whole bag of this popcorn has 3.5 servings. So servings are on bottom here. Servings. They want to know, of course, how many calories would that equal. So how many calories? So again, we can cross multiply. Or I can already see that 1 times 3.5 is 3 times 3.5 is 3.5. So that's going to be the same thing up here, times 3.5. I'm going to go ahead and jump to that equation really quick. 120 times 3.5, and that's 420. X equals 420 calories in 3.5 servings. And you can see that if I were to cross multiply, that's really all I'm doing, right? 3.5 times 120, 1 times x is just x, and there's our answer. So no matter how you slice it, it's coming out the same way. And that's what I love about math, is there's no one way to do most problems. You can do it multiple ways. Josiah went to Mexico for spring break and changed $325 into Mexican pesos. Let me get my pen out. So $325 into pesos. At that time, the exchange rate had $1 US is equal to, so this was the rate, $1 US dollar was equal to 12.54 pesos. How many Mexican pesos did he get on this trip? So how many pesos here? Notice again, I kept my dollars up top and my pesos on the bottom. And now it becomes easy. X times 1 is just X. 12.54 times 325 is going to give me my answer. I'm going to go ahead and put that in. 12.54 times 325 gives me 4,075.5. And answering that question, I need to put pesos. So that's how many pesos we can get for $325. Those are both equal. Write percent equations as proportions. Some of us would appreciate doing it this way, so let's look at it. The amount is to is to the base as a percent is to 100. So percent part is really easy. It's per 100. The base is going to be, you're going to hear this written a lot of ways. You're going to hear this written your total and your part, or part over whole, I should say. It's going to be part over whole. Maybe not total, but it's the same idea. And you're going to see it written is over of, because whatever follows the of is going to be on the bottom and the is on top. And I'll show you what we mean here in this problem. So let's set this up. I already know it's going to be a proportion. And I see 75%. What number is 75% of 90? So that's the total, that's the whole thing, that's the base, however you want to call it. And I'm looking for the is. What number is the piece of 90? So if I cross multiply, because I can't see any easier way of doing this, so I cross multiply, I see 100x, 100, and 90 times 75. When I multiply those, I get 90 times 75. And that gives me 100x equals 6750. Divide that by 100, which is pretty simple. Don't need a calculator for that, because all we're going to do is move this decimal that's here 1, 2 spaces back and give us 67.5. All right, another problem. 19 is 25% of what number? 19. So the setup is the part that's most crucial. 25%. 19 is of what number? So we're trying to figure out of what number. This is 25x. 19 times 100 is 1900. We're going to solve this by doing 1900 divided by 25. And we get 76. So does that make sense? Yes, because this number on bottom we expect it to be bigger, because 25 is smaller than the bottom number. So this number should be 4 times, and I should have said it that way. So this number is 4 times bigger. Well, I could have just done that. This is 4 times, and that's a little shortcut that you should employ that will help save time, which could have saved me a lot of time than trying to multiply all that out. I could have just said 19 times 4 and got 76, because 20 times 4 is 80. Take away 4, 76. This one looks pretty simple. What percent? So what percent? We don't know that piece on top. Of 27 is 9. So what percent is this? Looking across, I can't see any clear way to get there quickly, but looking here I can. If I can find a factor that goes from 9 to 27, well, that's times 3. So some number times 3 will give me 100. Well, that's not a perfect number, but I know it's going to end up being 33 1/3 times 3. To prove it to you, we'll put in the calculator anyway. Actually, let me set it up first. It'll be 27x equals 900, and then divide both sides by 27. X equals what? I'm pretty sure we know what it's going to be. 900 divided by 27. Yep, just as expected. 33, 3, 3, 3, 3, 3, 3, which is 33 1/3. All right, what number is 45% of 80? Again, the setup is the most important part. 100%, 45% of 80, and we don't know that. Which is there easy to kind of look across and look for a factor? No, we can't see a factor going from 45 to 100 because I can't multiply by 2 and you get that answer. So I'm just going to go ahead and do it the cross multiplying way. So that's 100x is equal to 80 times 45. 80 times 45, 3600. Divide both sides by 100. And that looks pretty easy, because this is going to take out these zeros, because moving this back 2 spaces is 36. Skip one. We want all our practice problems, so I don't want to skip that one. Especially this one, actually. This is a good one. Make sure you're practicing this before you work it with me, please. 125%. 125% of 25 is what? So again, I'm looking across to see if there's an easy way for me to do this, and I noticed that I can multiply 25 times 4 to get 100. So something times 4 will give me 125. What times 4 will give me 25? Well, it's not a quarter. 30. We could divide to find out. So let's pull out a calculator. We can go backwards and say 125 divided by 4. And there's that number. 31. So x is going to be equal to 31.25. Now, I didn't do it through the system that I just showed you, so I'm going to be sure to work it that way too. If you can watch here, I'm going to cross multiply these two to get 100x, and then multiply 25 times 125 and get 31.25. Dividing by 100 is simple because I'm just going to move the decimal 2 places. So that's going to go 1, 2 to 31.25. So which is easier? If you can see the relationship here, I think it's so much easier than trying to write out all the steps. But it's a great way to check yourself, as you see I'm doing. All right, what percent, so we don't know this, what percent, I keep making these look like 6s, of 72 is 9. So this one looks kind of easy because I already see there's a relationship here where I can multiply by what number? 8. So something times 8, something times 8 would give me 100. Well, it's not going to be a perfect number, but I could work backwards and figure it out by simply saying what? 100 divided by 8 would give me 12.5. And honestly, that's the way I work these problems. I know we can go 72x and then equals 900 and divide both sides by 72, which gives us 900 divided by 72. 900 divided by 72. See, same answer. So I already know this is going to be the same answer. But for you, if you get comfortable doing it with the equation and still not sure of how this works, well, keep doing it and go with the one you feel most comfortable with. But since I've done it so many times, I know it works, and I'm not going to have to go back and do it twice. Work it in 2 different ways. All right, so that is it. Did we answer our questions? We define proportion. We set it up. How do we solve proportions? We talked about how to solve them. If there's an x there, we can cross multiply, or you can just look across and look for the factor, which is not formally in the lesson, but I've learned does work pretty easily with proportion. How do we solve applications using proportions? If they're in word problems, we work them the same way. Just make sure you keep your units in the same place, all on the numerator or all in the denominator. How do we write percent equations as proportions? And how do we talked about that, percent equations right here. Just make sure you sit up this way with your is over of and your percent up here. I shouldn't say percent, whatever that number is. How do we translate and solve percent? Well, we're going to work it the same way. We can go across, multiply, or you can look for some kind of factor that's in the way I talked about. Like if they're both being multiplied by 3 in the numerator, multiply both sides by 3 in the denominator. Name is Brandon Clayton. Thanks for tuning in, and I will see you next lesson.